Rationalise the denominator of each of the following. So for part A, we have 2 divided by the square root of 7, and to rationalise the denominator, we need to multiply by a fraction that's equivalent to 1 that will give a whole number on the bottom line. So we know that the square root of 7 times the square root of 7 would give 7, so we're going to multiply by the fraction square root of 7 divided by the square root of 7. In doing so, we don't change the size of the fraction or the number, we just rationalise it. So multiplying across the top line, we have 2 times the square root of 7, and multiplying across the bottom line gives the square root of 7 times the square root of 7, which is 7. So we now have a rational denominator, and they are in fact the same value. For part B, we have 12 divided by the square root of 3, and once again we're going to multiply by the fraction that's equivalent to 1 that will rationalise the bottom number. So if we choose the square root of 3 divided by the square root of 3, we'll rationalise and have 3 on the bottom line. So that will give 12 times the square root of 3 multiplying across the top line, divided by 3 by multiplying root 3 and root 3 on the bottom line. Simplifying that, 12 divided by 3 is in fact 4, so this answer is 4 root 3 when we rationalise the denominator. For part C and D, we're going to need to use a slightly different method to rationalise. So instead of just multiplying by, say, root 3 over root 3 or root 6 over root 6, we're actually going to need to use DOPS, which is the difference of perfect squares. So we know that DOPS means that A plus B times by A minus B gives A squared minus B squared. And it's this expansion pattern that we're going to use to rationalise denominators when you have things like 5 plus root 3 or 2 minus root 6. So this time we're going to multiply by 5 minus root 3 divided by 5 minus root 3. So once again that fraction is still equivalent to 1, but now when we expand the bottom line it's a difference of perfect squares where we have no middle term and we simply have the first term squared minus the last term squared, which should give us a whole number. So multiplying across the top line we have 2 and then we have bracket, which means we're timesing by 5 minus root 3, so that bracket's important to have, divided by, and the bottom line is going to give us 5 times 5, which is 25, and then we're going to have minus the root 3 times root 3, and that just gives 3. So simplifying that down, we have 2 bracket 5 minus root 3, and then we have 22 on the bottom line, and 2 is a common factor to the denominator and the numerator, so this can just be written as 5 minus root 3 over 11. So that's the answer with a rational denominator. For part D, we're going to multiply this by 2 plus root 6, so again we're using the DOPS expansion. So instead of having a negative sign here, we need a positive sign, so we flip the sign on the surd to rationalise this. And then multiplying across the top line, we'll have root 3 times 2 plus the square root of 6. And then on the bottom line, using this DOPS pattern, we have 2 times 2 is 4. And then we have minus the square root of 6 times the square root of 6, which will give just negative 6. Simplifying that, we have 2 times the square root of 3 plus the square root of 3 times the square root of 6, which gives the square root of 18, divided by 4 subtract 6, which is just negative 2. Now the square root of 18 can be written as the square root of 9 times 2, which equals 3 root 2. So we're just going to simplify our answer, meaning this can be written as 2 times the square root of 3 plus 3 times the square root of 2 divided by negative 2. And as neither of the terms up the top have the same irrational factor, we can't combine them in any way, so that's the final answer for part D.